Okay, so yeah, now it's being recorded. What was the other question?
So would the test be like the quiz where it's posted up and we have like all day to do it and
No,
we just have to get it done by the end of the day?
no, the test is no, the test you can have like a specific amount of time. So honestly, this test is not being run by me. Like I'm not making the test, I'm not setting anything up. Um, so it's all being run by the coordinator of the course. I think you're going to have like 4 different opportunities to take it during the day, like during the 23rd, but you have to choose one of the times that you want to take it and take it during that time, and you have a certain amount of time to take it. I think you're going to probably be proctored. I'm not sure.
Okay, thank you.
Professor, I have a question. Do we have a sample exam, and could you please upload the
Yeah. So
sample
this
and the
so
solution?
this is a sample exam. So I'm going through it, and I'm gonna upload it to the website page or whatever, to Canvas. Okay. But this is
Perfect.
basically
Thanks.
the, yeah, sample exam. Okay. So now they want us to find the angle between the vectors a and 2.7a. So that's just multiplying a by a constant. So they're going to have the same, they're going to be pointing in the same direction. So the angle between them is going to be 0. And then they want us to find a vector of length 3 in the opposite direction of a. So the easiest way to do this problem is to first find the unit vector of a. So we need to find the magnitude again. So like we said, the magnitude of a is equal to the square root of 7 squared plus 2 squared, okay, plus 4 squared plus 2 squared. And so then a over the magnitude of a, well, that's our unit vector. So I'm going to call that u hat. So that's our unit vector in the direction of a, whatever number this is. And so then a over the magnitude of a times 3, this has magnitude 3, and then you just put a negative over here, and this is the answer. So this over here, if I put in the 3, is going to be negative 21, negative 6, and negative 12. All of this over, and I'm just going to leave the magnitude of a. Okay. Any,
Um,
yeah.
where did the negative come from again?
So we're trying to find the vector in the opposite direction of a. So that's why you put a negative.
Okay. I know you went through 3 and 1 already. Do you mind going over them real quick again?
Um, yeah. So number 1 is find the vector between a and 10a cross b. And we know that a cross b is orthogonal to a. So there's a 90 degrees angle between a cross b and a, and just multiplying a by 10 doesn't change that. So there's a 90-degree angle between a and 10a cross b. In order to find this over here, the vector between a and b, we just looked at the formula that the angle between two vectors is cosine inverse of a dotted with b over the magnitude of a times the magnitude of b. So then just plug in here what you need to, and you'll find that angle. Okay, and then D is what we just did. Okay, any other questions?
And then you said C, since it's going the same direction, there's
Yeah,
no angle. Okay,
yeah.
thank you.
The angle is 0. Yeah. So now they want us to find the equation of the plane that contains the line. So this line and this point. So there are a couple of different ways that we can try to do this question. I think the simplest way, like this. So what they want is they give us a point. Here's a point P, and they give us a line, and they want us to find the plane that goes through this, that contains this point and also contains the line. So whatever. So here's our plane. So one way to do this is to pick the point R0 on the line. So we know that every single line, R of t, is equal to R0 plus TV. So we can pick the point R0 on the line. And then we know that the vector V starting at R0, wherever it is that it ends, is also on the line. So we can look at the vector V, and then we can look at the vector from R0 to P. So this is the vector R0P, and we have the vector V. So these are two vectors in our plane. So then we just need to take their cross product, and we will get the normal vector to the plane. So here, this is the vector R0P cross V, and it's the normal vector to our plane. And then we have a point in our plane. We will have the normal vector, so we will be done. So any questions about the overall strategy?
Could you explain that again?
Yeah, so you have a line, we have a line, and we have a point. And we want to find, okay. So you want to find the plane that goes through this point and also this line. So anytime we know that any plane, the properties of a plane are that they have the normal vector. So they have a normal vector that we need, and then we need a point on the plane. Let's call this P0. And then we know the formula for this plane, and the formula for the plane is AX plus BY plus CZ is equal to D, where A, B, C, these form the normal vector. And, okay, I'm just going to continue here. And then for P0, let's say that this is X0, Y0, and Z0, then D, this D over here, is equal to A X0 plus B Y0 plus C Z0. So what we need in order to find a plane is we need a normal vector and we need a point. So how can we find this normal vector? Well, a good strategy is to always find two vectors that lie in the plane and take their cross product, and that will give you your normal vector. In general, if you have 3 points, you can always find a plane that goes through those 3 points. So let's say you are given 3 points. So here's your coordinate system, X, Y, and Z, and you're given 3 points, and you want to find the plane that goes through these 3 points. So what you do is you find this vector over here and this vector over here. So yeah, let's imagine this is P, Q, and R. So you find the vector PQ, and we did this, and you find the vector PR, and then you take their cross product, and that gives you this vector over here, and that's going to be the normal vector of your plane, and then you can choose P to be P0. So again, when we're doing the problem that they just mentioned, we have a line, so we can choose a vector on the line, and the vector V always does that trick. And then you have another vector over here, and it's the vector from R0 to P to our point, and you can take the cross product, and that will give you our normal vector. So now to actually do the problem. So any questions about this before I erase it? Okay, so now the point is 2, 5, 5. So I'm going to call P 2, 5, 5. And then the line was 2 plus 3t, 3 plus 2t. So 2 plus 3t, 3 plus 2t, 3t. This is our R of t. Sorry, 2t. Okay, and again, they want us to find the plane that contains this line and this point. So let me just draw the picture again quickly so that we have an intuition for what's going on. Here's the point P, here's the line R of t. So the first thing that we want to do is we want to find a vector on the line. So this line over here can be rewritten as 2, 3, 0 plus t of v, and v over here is going to be 3, 2, and 2. So now we know that v is equal to 3, 2, and 2, where, well, we can rewrite this again. So this is R0 plus TV. So that's one vector. And if the plane is going to contain this line, it's going to contain this vector, assuming that the vector, I put the vector at R0. Okay. So now we want the vector from R0 to P. So we want the vector R0P. So that's the vector P minus, or sorry, the point P minus R0. So R0P, that's going to be equal to, so then we're going to have 2 minus 2, which is 0, and 5 minus 3, which is 2, and 5 minus 0, which is 5. So that's the vector going from R0 to P. Any questions about this? Okay, so now let's take their cross product. So, so the normal vector is equal to I, J, K, 3, 2, 2, 0, 2, 5. And this is I, so the I times 10 minus 4 minus J times 15 minus 0 plus K times 6, which is going to be the vector 6, negative 15, and 6. So this is our normal vector. So we know that our plane looks something like that. Now, that means that our plane has the form 6x minus 15y plus 6z is equal to some d. Now, if we choose the point R0, so this is the point R0, and it lies on the plane, so we can say that 6 times 2 minus 15 times 3 is equal to our d. In other words, 12 minus 45 is equal to d. And this is equal to 33, negative 33. Right?
Why do we plug in R0?
What?
Why do we plug in R sub 0?
Well, it's any point really. So any point on the plane, we can choose this point, that we can choose the point P, or we can choose the point R0.
Professor,
Yeah.
so because when doing cross product, I crossed R0P cross V. That's why I got the normal vector opposite from yours. And my equation is all opposite signs. Is that okay?
Yeah, because this side of the equation is probably you have opposite sides, but also you're going to have 33 instead of negative 33.
Yes. Okay.
Okay. So this is the equation of our plane. And now let's see if, so let me just rewrite it. 6x minus 15y plus 6z is equal to negative 33. So let me erase this. So let's see if our point P is in this plane. So this is going to be 6 times 2 minus 15 times 5 plus 6 times 5. Just use a calculator quickly. So 12, 15 times 5, 75. So this is 12. 70. Okay, and then it's 30. And so then this is 12 minus 75 plus 30. Yeah, so this is equal to negative 33. So this point is on the plane, this point is on the plane, and we can also try for t is equal to 1. We can try to see if that point is on the plane, but I wouldn't be surprised if it is. So let's continue to the next problem. So now they give us a sphere. They want to find they want us to find the center and the radius of the sphere, and they want us to find the shortest distance between a point on the sphere and the point 5, 2, 3. Okay, so let's first begin by finding the center and the radius of the sphere. So this is x squared plus y squared. Okay. X squared plus y squared plus 4y plus z squared minus 4z is equal to 13 minus 4z. Okay, so this is the equation that they give us, and we just need to complete this square, meaning we don't like this over here and we don't like this over here, and we want everything to be squared. So the x's are easy. So the x we just keep the same, x squared. And then the y over here, so you can say plus y squared plus 4y plus 4. And then for the z, you can say plus z squared minus 4z plus 4. 1 second. 2, it's basically, yeah, it's going to be negative. Okay, so plus 4. Okay, and so we added 8, so this is going to be equal to 21. And so then this gives us x squared plus y plus 2 squared right? So y plus 2, y squared is that, and then 2y and 2y gives you 4y, and then 2 times 2 gives you 4, plus, and then over here, we're just going to do z minus 2 squared, and this is equal to 21.
What are we trying to do with this problem again?
We're trying to find the equation. So we're trying to, they give us a sphere, and we're trying to find the center and the radius of the sphere. That's the first problem.
Okay.
So we now know the answer. The center of the sphere is going to be 0 for the x, -2 for the y, and 2 for the z. So that's going to be our center. And our radius is the square root of 21. Any questions about this?
This might be a dumb question, but what's the formula for completing the square again? Was it just like b divided by 2 or something?
Yeah, that generally, I mean, you have to be a little careful with the sign, but you look at the, let's say for y, you want to get 2 of them, so you divide them by 2. Yeah.
Okay, thank you.
I don't think they're going to give you a question where it's hard to complete this square. Okay. Fine. So now we have that. So now they say find the shortest distance between a point on the sphere and the point 5, 2, and 3. So if here's the point 5, 2, 3. And then we have the point whatever 0, -2, and 2. Okay, so now what we can do is we can find the distance from the center of the sphere to this point. Now obviously the sphere, wherever it is, let's say it does something like this, at some point the line that we choose is going to go right, it's going to touch a point over here. And so this distance over here is the square root of 21 because it's the radius. So we just need to subtract this distance, the square root of 21 from the entire distance, and we're done. Because that's the, did they want a specific point? Let me see. No, they want the shortest distance. So that would be the shortest distance. So let's find the distance between this point and this point. So it's the same as finding the magnitude of the vector between them. So if I call this point Q and I call this point P, I'm looking for the point PQ, the magnitude. So then this is equal to the square root, and then I'm going to have 5 minus 0, which is 5 squared, plus 2 minus minus, so this is 4 squared, plus, and then 3 minus 2, which is 1 squared. So this is going to be the square root of 25 plus 16 and this is going to give us the square root of 41. So now the shortest distance is going to be the square root of 41 minus the square root of 21. Okay. Any questions about this?
Should it be 42?
Very possible. Well, this is 6 and 5, so that would just be 1, no?
And then plus the 1 squared.
Oh, I forgot that. So, yep, you're right. Okay. Any other questions? Okay. So now they want us to find the values of C so that the line R of t is equal to this, does not intersect the plane, this plane. Okay, so let's see how we can think about this. So let me rewrite my R of t. Anyone have any idea how to do this?
Can you go back to the question real quick again?
Yeah. Can someone tell me what R of t is? Sorry, R of t is equal to what? Nope. Okay, R of t is equal to 2 plus t, 2 plus t, 2 minus ct, 2 minus ct, and 3 plus t, 3 plus t. And then the plane is 5x plus 3y plus 2z, 5x plus 3y plus 2z is equal to 7. Okay, any ideas for, so they're trying to, they want us to find a C so that this line and this plane do not intersect. So any ideas of how we can do that? Okay,
We
so,
find. Sorry, go
yeah,
ahead.
no, you.
Yeah, we find where they intersect first.
So, okay, so let's say you find where they intersect, then what would you do?
Not.
I mean, because so first, what C is just going to change, so you can't even find where they intersect. It depends on C. So I think that geometrically, it's easier to try to think. Yeah, sorry.
Parallel.
Yeah. So geometrically, it's easier to try to think about making these two things parallel, making this line and this plane over here parallel. So if we rewrite this line, it's going to be, okay, let me first just rewrite this here. 5x plus 3y plus 2z, 7. Okay. So if I rewrite this line, I'm going to get 2 and 3 plus t of 1, negative c, and 1. Yeah. Okay, so now we have our normal vector over here. So our normal vector to this plane is equal to 5, 3, and 2. So in our picture, we have our plane. So here's our plane, and it has its normal vector n. So that's the normal vector. And then we have this line over here. And if we could just have that the line maybe does something like this, then it will not intersect our plane. But what we need to do in order to have our line be parallel to our plane is we need the vector v that constructs the line. We need this to be orthogonal to the normal vector. So v needs to be orthogonal to the normal vector. And then if that's the case, as long as this point is not on the plane, so as long as you don't start at the plane, you won't continue on the plane. So if you're here, you will continue on the plane. But if you're here, you won't continue. So I need the dot product of this thing and this thing to be equal to 0. So let me just set it to 0. So this is going to be 5 times 1 minus 3 times c plus 2 is equal to 0. So that tells me that negative 3c is equal to negative 7. And this tells me that c is equal to 7 over 3. Yeah?
Can you explain where you got those numbers again?
Yeah, so you're taking the dot product between this vector v and the normal vector. Because you want the normal vector and the vector v to be orthogonal to each other. Because,
Okay.
yeah, you don't want the line to go through the plane at any point. So you want it to be parallel to the plane. So you want the vector v and the normal vector to be orthogonal. So you take this and you dot it with this. So you get 5 times 1 minus 3 times c plus 2 is equal to 0. And then you just solve for it, and you get that c is equal to 7 over 3.
Okay. Thank you.
Pleasure. So now all we really need to do to finish the problem is to check that the R0 is not in the plane. So that's going to be, so let's plug it into the plane and see. So that's 5 times 2 plus 3 times 2 plus 3 times 2 is equal to 7. Well, is it? So this is 10, and this is 6 and 6, so no. So that finishes this problem. Any questions?
Can you explain real quick where you got those 3 2s from?
The 3 2s?
Yeah, like you put like 2, like that, like like 5 times 2 plus.
Yeah, I'm just plugging this problem, this point, into this into the plane to see what happens. The x goes into the x, y coordinate goes into y, the coordinate goes into the z.
Oh, okay. Thank you.
Okay, so I think I'm going to stop here for today, and we're going to continue the review next week. I'm going to post this video and have the other videos on YouTube. You're going to have the page with the references to all the material on the exam, and I'm going to also post the tests, these like tests that we've been going through. And that's basically that. Any questions?
Do you know how like long the test is gonna be? Like, will it be like the same as the practice test?
Yeah, I think it's going to be like 6 questions altogether.
Okay. Thank you.
Anything else? Okay, have a nice day.